Algebra lesson 2-1, 2-2, and 2-3. We have a number of words that we use to describe different types of numbers. First one we have is real numbers. Real numbers are going to be any number that you could put on a number line. So that would be fractions, that would be terminating decimals, or decimals that have a repeating pattern to them, or they would be just regular old numbers that don't go on forever without pattern. We can look at this box right here as representing rational numbers. Rational numbers is another phrase for real numbers. So that box contains all the real numbers that exist. They would be able to be found in there. Next we have what we call natural numbers. Natural numbers have no decimals, no fractions, and 0 is not a natural number. 1, 2, 3, 4, 5, 6, the dot 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 means it continues on forever. So again, no decimals, no fractions, no negatives, no 0. After natural numbers is whole numbers. The only difference between natural numbers and whole numbers is the 0. The exact same values here, no decimals, no fractions, but 0 is an addition, which means that every single natural number is in fact a whole number. But not all the whole numbers are natural numbers because 0 is not a natural number. Both of these values are real numbers. Every single number you see here can be put on a number line. And lastly, we have integers. Now, integers are a little different. The only difference really is that they go into the negatives. Again, no decimals, no fractions. Goes on forever this way, goes on forever that way. Now, to look at this in terms of my boxes, again, rational numbers represents real numbers. Anything that could be put on a number line, decimals, fractions, whole numbers, natural numbers, would go in here. And inside this is another subgroup called integers. Because every single integer, remember, no decimals, no fractions, but positive and negative numbers, every single integer is considered to be a real number. But then there's a special group, because remember, these are positive and negative whole numbers, and 0, no decimals, no fractions, but there are some numbers that are special in here, which we would call the whole numbers. Every single whole number is an integer, but there are some integers that aren't whole numbers, like all the negatives. None of the negatives can fit in this group. It's like an exclusive group inside. And then inside the whole numbers is an even more exclusive group, because they don't allow the number 0 into natural numbers. But every natural number, 1, 2, 3, 4, 5, 6, 7, 8, 9, forever, is a whole number. And every whole number is an integer. And every integer is a real number or a rational number. Numbers we call irrational numbers would be numbers like pi that continue on forever and never have a pattern repeating to them. We can find no ending. We can approximate where they go on a number line, but we can't be exact. Negative numbers are left of 0 on a number line, and the farther that you go left, the actually smaller your value becomes. That's really difficult because what a lot of people think, and they go, negative 100 is smaller than negative 10? Oh yeah. It's way farther left on the number line, so it must be smaller. The farther we go to the right, dealing with positive numbers, the larger the value becomes. So if you had a positive 50, and you were comparing that to negative 100, even though this seems like it's bigger, it's actually really small in comparison to 50. Because any negative is going to be smaller than any positive. Even 1 is bigger than negative 100. Numbers to the right are positive, numbers to the left are negative. Now the boxes I just used are a form of what we would call a Venn diagram. They represent the groupings or the sets of numbers. So the blue circle is all the people that like the blue color. The red circle is the people that like all the color red. The purple circle is all the people that like the color purple. Anybody in here likes blue and purple. Anybody in here likes blue and red. Anybody in here likes red and purple. So there's still a red favorite, and they still like red, and they still like blue, they just like them both. Anybody over here only likes red. Anybody in the middle likes all 3 colors. That's why they're part of all the groups. Now, we just did a Venn diagram, and I had the natural numbers in its own group. But all the natural numbers happen to be part of the whole numbers group. There are some whole numbers that are not naturals. 0. Therefore, it's not every single one of them are going to be natural. But all the whole numbers are part of the group called integers. But all the negative numbers that are integers are not whole and they're not natural. But every single one of these numbers can be put onto a number line. So they would all be considered real. And then anything outside the real realm would be irrational numbers. You can use these numbers, and you can graph them on number lines. Anytime we put it on its location on a number line, that would be referred to as plotting. So if you're asked to plot a point, look on the number line and put a dot on the number line that corresponds to that number's value. That corresponding number is known as a coordinate. It's the place that it matches on the number line. And we can use a number line for helping us to add positive and negative numbers. It's not a requirement, but if you are struggling with dealing with positive and negative numbers, it can help you. You always start at 0, so this is your start. The very first number I was given was a positive 2. Positive numbers are to the right, negative numbers are to the left. So positive 2 means I must move to the right 2 places. But I don't stop there, because then it says to add a negative 5. Well, negative 5s aren't going to continue to the right, they're going to make me turn and come back to the left. So I go back 1, 2, 3, 4, 5 places, and I end at negative 3. If this had been the other way around, and the first number was negative 5, I would have gone 5 places back, and then I would have turned and gone 2 places back to the right, and still ended at negative 3. So the order of addition won't matter, but I have to start at 0, go left or right according to the first number, and then left or right according to the second number. Even if it's 2 positives, if I had gone to the right 2 and then to the right 5, a positive 5, I'd be at 7. So it still works. If you're struggling with those numbers, you can use a number line. Absolute value. This one's tricky because people mix it up with the word opposite. In fact, absolute value has nothing to do with opposite. It means how far something is from 0. Alright? This is the symbol. 2 bars. Now you got to be careful. If you write down this, then I know you're talking about the absolute value of 2. But if you write down this, I don't know if you mean the absolute value of 2 or if you're talking about 121. So you need to be very careful. They don't need to be ridiculous. You don't need to draw lines like that big. Just enough that we know it's not a number. Okay? Now what I'm saying is the distance from 0. Here's 0, here's 3, here's negative 3. What's the distance that this number is right here from 0? It's 3 units away. I know it's negative, but it's 3 units away. Over here, again, same thing. 3 units away. That means the absolute value of negative 3 is 3. And the absolute value of 3 is also 3. Most people see this right here and they go, oh, it means opposite. It does not mean opposite. It means how far away it is. Pretend this is the school, and this is my house, and this is your house. Would you say you're negative 3 blocks from the school? Or would you just say you're 3 blocks from the school and I'm 3 blocks from the school? We're both 3 blocks from the school. It's how far away we are from the school, not positive or negative. It comes into play, absolute value comes into play when we talk about velocity. Now velocity is speed, which we are used to, but also with direction. So if you're truly given velocity and it's a positive number, you know that the object is going up. If you're given a velocity and the number is negative, you know the velocity or the object is going down. If you just want to know the speed and you don't care whether it's going up or down, then you just take the absolute value of the velocity. Because once again, the absolute value of both the positive and the negative is going to be a positive. So I throw an object up in the air at 200 miles an hour, the velocity is positive 200 miles an hour. Positive 200 plus miles per hour. If I throw an object down at 200 miles an hour, it's going to be negative 200 miles per hour. The speed of both objects is 200 miles per hour. The positive tells me up, the negative tells me down. And a counterexample. If you make a claim, it just takes one counterexample to prove that claim wrong. You don't have to prove it's wrong 15 times. Just once will make the claim wrong. So if your parents say, you never clean your room, as long as you've cleaned it once, the word never doesn't apply anymore. Now, if they say you rarely clean your room, then they've got a point there, possibly. If you say, Mr. Corey always parks in the same spot, it just takes somebody else to park in my spot or me to park somewhere else to disprove that claim. You don't have to prove it over a week's time. You just have to find one time where that doesn't actually happen.